Today we are adding, sorry, I'm shaking the camera, compound and, which is page 46 into our notebooks. Okay, just like we had yesterday, you're gonna have a foldable to add in with compound and, so make sure you're cutting along the dashed lines and gluing where it says glue here, and then your examples are going over on the right-hand side. Okay, so just like yesterday when we are talking about compound inequalities, we are talking about having more than one inequality. So we're gonna have more than one today as well, but now they are going to be attached with the word and. Now, when we are looking at compound and, we may see the word and, or we might have to assume the word and. With or, we always saw it. With and, we might not. Okay, same types of ways that we can represent it. So if we start by looking at graphing, you will notice right away off the bat when we look in here to graph this, we do not see the word and. Okay, and that is because we can instead sort of link them all together in one big chain, right? -9 is less than or equal to x and less than -4. I don't need to repeat that x like I had to for compound or. However, to graph a compound and, it's much more beneficial for us to have it written as two separate pieces. Okay, so if we want to look at this to graph it, we actually need to think about this as two separate inequalities. The one over here is the easiest because it reads just like normal. X is less than -4. Okay, now this inequality, when we read it, right, we're duplicating that part in the middle. That's where that and piece comes in. It belongs to both. Okay, if we write this down, we get -9 is less than or equal to x. But remember, that's not going to help us when we graph it. So we really want that variable first. So now we have x is greater than or equal to -9. And I'm going to write this in a different color because it's going to help us in a minute. X is less than -4. So just like before, we are going to put our smaller number on our number line on the left. Okay, so I'm going to put my -9 over here. It seems larger, but it's more negative, right? So it's smaller. And my -4 on the right. And just like yesterday, I'm going to graph above. So at -9, I'm putting a solid circle, and this tells me to shade to the right. At -4, I'm putting an open circle, and it's telling me to shade to the left. Now, yesterday, we would have looked at this and said, oh, this means all real numbers. But that was for a compound or. For compound and, right, if we get one and the other, it means that we get both. So we need to be looking for anywhere that we see both of them. So if I look over here in this section, I only see the blue, so that's not both. If I look in the middle, I do see both. If I look over here on the right, I don't see both, and so my final answer is just this info in the middle. Huh? When we look at this, if we want to write this, right, we have to sort of think about this as two separate pieces. We have one going like this, and we have one going like this. We don't have that luxury like we did yesterday of them just looking like two separate inequalities. So we have one that's telling us an open circle. So x is greater than, but not equal to, -2, right? It's shaded to the right. And we have one going the other direction. So x is less than, because it's going left, but it's a solid circle, so it also gets the or equal to. Now, while if this was just free response, this would be enough for the answer, it's not enough of how we would, it's not what we would typically see. So multiple choice or anything like that, this isn't really the way we typically write compound and, which means we want to get them squished back together like we saw that answer over here. Okay, to do that, we want to see our x's both in the middle. So we're going to do this reverse process. We're going to rewrite this with our x in the middle. If we're rewriting, we have to flip the inequality sign. And then we're just going to cut out where that's duplicated. So since that x is happening in there twice, we're just not going to write it twice. We're going to squish it together into one big string. Now, knowing that compound inequalities are now stuck together, that means solving compound inequalities also looks very different. We no longer just have two separate inequalities that we're solving completely separate from each other. Instead, we have one big chunk that we need to solve as one big piece all together. Okay, so if we look at this, what we want to do is, for the just brief moment, ignore this stuff on the left. Don't ignore anything in the middle. Just up past this first inequality and say, okay, what if I were to solve b over 3 plus 5 is less than or equal to 13? The first thing that I would do is subtract 5 from both sides. The difference is that in a compound inequality, we have 3 sides. We have a right, we have a left, and we have a middle. So we don't want to do it to both sides. We want to do it to all 3 sides. Okay, and we're still going to bring down like normal, but now we just have 3 columns to worry about. So -4 minus -5 is -9. Those still cancel out like in a normal equation. We just have to calculate both sides. So 13 minus 5 will give us 8. And then we'll repeat that process. What if I only had this part here? Well, I would undo division with multiplication. And normally what I do on one side, I do on the other, but now I need to do that in all 3 places. Okay, so that will give me a -27. Less than b. Now, I multiplied by a +3, so I'm not flipping an inequality sign. If I multiplied by a -3, I would be flipping both inequality signs. Okay? So now if we go to graph this, our smaller number on the left, our larger number on the right. Okay, so we have b is less than or equal to 24. So this one right here is a solid circle going to the left. Okay, this one right here, we have to remember to rewrite. And when we rewrite, we flip the sign. So that is an open circle to the right. Oh, this one to the left. I might have said to the right. That one's to the left. Okay, and we want where they are both happening. Okay, they are both happening in the middle. So that's what's going on our number line. Okay, so all this stuff in the middle is a possible solution. Okay, now, this graph was in the middle, this graph was in the middle, but that does not mean all of our graphs will be in the middle. Okay, so if we look at this one, we said we could see the word and, so this one happens to have it written as 2 separate inequalities. So just like compound or, we'll solve these as 2 separate inequalities. Okay, so I'll divide by -2. A negative divided by a negative is positive, but I divided by a negative, so I have to flip that inequality sign. And I want the variable first, so I have to flip the inequality sign again. Okay, then I'm going to look at my other side. So if we subtract 2 first, then we can multiply times our 3. And then finally add our 5. Okay, so on our number line, we want the smaller number on the left, the larger number on the right. So 4 is a solid circle shaded to the left. 29 is a solid circle shaded to the right. And remember, we want to bring down anywhere we see both. So do we see both here? No, I only see 1. I don't see anything there. I only see 1. So we don't have anything to bring down on our number line. So this one is actually a no solution. There's nowhere that we get both of them, and therefore there's no value that satisfies it. Finally, we can talk about writing them just like we looked at yesterday. Okay, so a number is between 10 and 22. So if we want a number in between, it isn't it, but it's in between, which means it can't actually be a number. So I physically want my variable in between. I want it in the middle. Okay, it's going to be greater than 10. So if I write this out as two separate, my number is going to be greater than 10, and my number is going to be less than 22. But again, remember when I write this together in one big string, this one stays the same, but this one over here has to get flip-flopped. Okay. Then our last one, you are purchasing a gift for a friend. You want to spend at least $15, but no more than 20. We want to write an inequality that will represent that. Okay, so this is going back to those key terms. If we want to spend at least 15, we want to spend more than or equal to 15, but we also want to be less than or equal to, right? No more than 20. If we put this together into one piece, right, this one's getting rewritten. So we'll have a 15 is less than or equal to x, which is less than or equal to 20. Okay, so similar to yesterday, some of these you're going to do on your own, but I will go through and look at some of these. So the first one, if we want to identify the solution from the given graph, yours is going to have a graph printed on it. My apologies that this one does not. Okay, but yours is going to have a graph that has this shaded in the middle, and we have a -7, and we have a 20. Okay, we're going to have a solid circle over here, and we're going to have an open circle over here. So, right, we said we kind of have to think about this as two separate things, where we know we have one graph going here, and we know we have one graph going here. So if we look at just the orange one, right, that's telling us that x is greater than or equal to -7. We also know that it's going to be less than 20. Our job is then to turn those into one thing, right? So if we reverse this and squeeze them together, we'll get a final answer of -7 is less than x, which is less than 20, right? And this will be our final answer. Our next one, right, if we go to solve this. So if we want to solve this, we are going to just consider looking at this and saying, what would we do first? The first thing that we would do is we would subtract 3. Okay, but if we do that to both sides, again, we're also doing that to the third side. Okay, same idea. We will undo division with multiplication. But if we're doing it to two sides, we have to do it to all three. Our 5s cancel. Okay, so our smaller numbers going on the left, our larger numbers going on the right. This inequality is a solid circle to the left. This inequality is a solid circle to the right, right? Because we really have to think about this in its other form. So where do we see them both? Well, we see them both in the middle. Okay, so you're going to do the next 3. This last one, approximately 20% of the time you sleep is spent in rapid eye movement, REM, which is associated with dreaming. If an adult sleeps between 7 to 8 hours, how much time is spent in REM sleep? Okay, so we know we're sleeping from 7 to 8 hours, but only 20% of that is spent in REM sleep. So it's not in between 7 and 8 hours, right? It's in between 20% of 7 hours and 20% of 8 hours. So we need to calculate those percents first. How do we calculate a percent? Right? If we want 20% of 7, we can either set up a proportion, which would be fine. We've talked about doing that, right? 100 on the bottom, 20 on top, 7 is the total, and we want to find the percent of it. So we will solve. So we'll get 1.4 hours. The other way that we can calculate a percent of something is to do multiplication, right? So we also know that we could take 8 times 20%, which is 0.20. And if we multiply those two things together, okay, we'll get a 1.6 hours. So it's somewhere between 1.4 hours and 1.6 hours. It could be exactly that. Okay, so when we're writing this, right, we're putting our variable in the middle. It could be less than or equal to 1.6 hours. Oh, nope, I lied. It says in between, not exactly. So we don't want an or equal to. Okay, our other one says that it could be greater than 1.4. And if we flip this and put it together in 1, we will get 1.4 is less than y, which is less than 1.6. Okay, it technically tells us to graph it, but we're not going to graph this one right now.